and welcome to this quick how to help video on finding the area and perimeter of sectors. So this follows on from finding the area and circumference of circles. So if you haven't seen that one, I've dropped the link in the description. It might be sensible to watch that first unless you're already very confident with finding your circles. Okay, so the area and perimeter of sectors. Sectors are just a section of a circle. Okay, so if I was to pick this up and pop it on here, you can clearly see that that is like a slice of pie. All right, it's a slice that's been cut from the center of the circle. All right, that then makes these edges here match this edge here. And we know that this edge here is the radius, which means that these are radii. They are the two radiuses or radii that make up the sector. So that's the first thing to know about sectors, that those straight edges are coming from the radius. You've then also got your arc, which is coming from part of the circumference, not the whole thing. Okay, so when you are looking at the perimeter of this shape, you have got the two edges to add to a part of the circumference. So we're going to look at that one first because that's actually harder than the area. So let's do that one straight away. Now, we only have two formulas available to us when it comes to curved shapes, and that is the area and circumference of circles, the full circle. So if I'm going to be doing the perimeter of this shape, I need some of the circumference, but my starting point has to be to find all of the circumference. So I know that the circumference of a circle is pi d. I have a radius in my sector, not a diameter. So I know the radius is 7, the diameter therefore is 14. So this is going to equal pi times 14, which is 14 pi. And if I was to put that into the calculator, then that could give me a decimal version. But something to be really, really mindful of. In fact, let's quickly put that in and write down the decimal version. Okay, so we've got 43.982 and on it goes. If I round at this stage, I am starting to change what the final answer might be because I've already cut some of the value out of the question, which I don't want to do. So it's actually far easier for me to stay in my terms of pi than it is for me to go into the decimal version. Some students definitely prefer to see decimals, but if you can, avoid changing anything at this stage. So if you're in a decimal, just write at least 4 decimal places down and then it won't mess you up at the end, okay? Now, what I've actually got in my answer is, okay, that answer is for the full circle, and I do not want the full circle, okay? So there is an extra step now in order for me to just find the arc. So I'm just going to drag this. I know there's a lot of colour on it now, but I'm just going to drag this back across and sit it back in place. You can see that that sector has been cut out of a circle that has a total of 360 degrees. This sector is 52 degrees out of the full 360. So what I have to do with my answer here is say I only want 52 out of the total 360 degrees of a circumference. Yeah, circumference is 360 degrees. I just want 52 degrees of it. Okay, of in maths means times. So I'm going to be doing 52 out of 360 times 14 pi. And that's going to give me my arc length, okay? And that is, now this is where we will go into a decimal, okay? That is going to give me 6.3529, and the dots are just saying it goes on, okay? So I've got that answer. That is my arc. So the arc is 6.3529, on and on it goes. I now need to add those two radii. So I'm going to add those two straight edges, 7 plus 7 onto that number. So I'm going to add my 14, and I've got 20.3529, and on it goes to one decimal place, 20.4, and it's perimeter, so it's just an outside edge, it's just length, so it's centimeters. So it has to start with a formula that we've got. We have to manipulate that formula, but the biggest thing people forget to do is add on those edges, because there's quite a lot of work to get to that point. A lot of people think they've finished, and they haven't. They've literally just found that first bit there. You've got to add in that, and that is your perimeter of a sector. Area of a sector, thankfully, is a lot easier. So area, oops, can't write in a light, can I? Area is pi r squared. The r I can see from my key is 7. So I've got pi times 7 squared, which is 49 pi. Okay, and as I say, be really, really careful, really mindful to, if you go to decimals, to not cut too much of it off, because we don't want to lose any part of the number in the kind of middle of the workings out. We only ever round at the very, very end. So this, remember, this answer here is giving me a full circle. I only want a fraction of the circle. We've talked about what that fraction is. We know that it is going to be, we'll just make a bit more space. It's going to be 52 out of 360, times that to my 49 pi, pop that into my calculator, and I've got 22.235, which is 22.2 centimeters squared, because it's area. Okay, so it is your normal formula, and your fraction comes from this angle here. If it had been 38 degrees marked in there, it would have been 38 over 360. If it had been 71, it would be 71 over 360. The only additional bit to the area is the fraction. And as we've already talked about, the circumference does have a little bit more happening to it with the extra edges. And that's it. That is how to find the area and perimeter of a sector. Okay, hopefully you have found that useful.